Welcome to the video for C6.1.12 Reducing Corrosion. So before we start this lesson, we need to look back at what we already need to know before this lesson. So from last lesson, we learned that corrosion is the reaction of a metal with chemicals in its surroundings, and those chemicals are normally the oxygen from air or water, normally as water vapour. And we'll also learn that corrosion is more likely if the metal is more reactive. We also learned about rust, which is a specific example of corrosion, which only occurs when the metal corroding is iron or steel, which is an alloy which contains iron. So before we start the lesson, we need to do our recap quiz of our previous knowledge. So if you're watching the interactive version of this, then your questions on the Office Forms quiz will pop up very shortly. So our learning objectives for today, so we need to be able to describe how physical barriers can be used to reduce corrosion, and we need to explain how sacrificial protection works. So last lesson we looked at what corrosion was. Today's lesson is all about how we can stop corrosion happening, because we make lots of objects out of metals and we don't want them to corrode, because then they become useless. So the main way of preventing corrosion is by using barriers. So in C5, you will learn, because we do things in a different order, we haven't done this yet. But in C5, you will learn, and we've done this at Key Stage 3, that chemical reactions occur when particles of the reacting chemicals collide with each other. So chemicals can't react with each other unless the particles of those chemicals can collide. So by using a barrier, we're stopping collisions between the reacting particles. So we already know that corrosion is a metal reacting with water and or oxygen. So if we put a barrier between the metal and the water or the oxygen, then it stops the reaction happening because the particles can't collide with each other. So I've got a bit of a rubbish diagram here, I'm afraid. You should be used to my dodgy Paint 3D skills by now. So on the left shows if we don't have a barrier. So you've got the metal object there, and it's surrounded by oxygen and water. And because it's surrounded by oxygen and water, the oxygen particles and the water particles can collide with the metal atoms, and a reaction can occur between them. So the metal object will corrode. On the right-hand side, that big purple box is supposed to represent a barrier. So you've got the metal object, and there's a barrier between the metal object, so it's coated in something, and that prevents the metal object from colliding with the oxygen and water. The oxygen and water particles can't collide with the metal atoms. So what sort of barriers can we use? So the type of barrier we use depends on what the object is. So there's 4 main barrier methods that we can use to prevent corrosion. So the first thing that you can do is you can paint an object. So you've all seen examples of this. So cars, buses, bikes tend to be painted, and that provides a barrier which prevents rust, which, as we know, is a form of corrosion. The other thing you can do, option 2, is that you coat it in oil or grease. So the best example of this is if you think of a bike. So the main body of the bike is going to be painted, but certain parts that need lubricating at the same time. So if you think about the bike chain, you can't paint that, otherwise it will stick. You want it lubricated at the same time. So if you cover the bike chain in oil or grease, then it does 2 things. First of all, it lubricates it so that the chain doesn't get stuck, and also it prevents it from corroding. The third thing you can do is you can cover your object in plastic, and the last thing you can do is you can plate it in a less reactive metal. So the best example of that is, we all know about tin cans that we get food in. So we call them tin cans, but actually they're steel. So the main metal in there is steel, but because we know steel rusts, and we don't want rust in our food, and it also damages the integrity of the can, that steel is then coated in a less reactive metal, in this case tin, and that prevents it from reacting either with the food inside or with the water vapour and the oxygen from the air. So the advantage of a barrier method for preventing corrosion is that it stops the reaction completely. So as long as the barrier is intact, there cannot physically be a reaction. It can also improve the appearance. So if you think about our cars and our bikes, then when you paint them, you can paint them a different colour. because it'd be really boring, wouldn't it, if all our cars were the same colour. Disadvantages. So the problem with barriers is that if the barrier is damaged, then corrosion can then occur. So if you think about your bike, if it gets scratched, or if your car, so I'm a bit clumsy driving my car, you can tell which one's mine in the car park because it's got loads of scratches down the side of it that have been painted over. So when I do scratch my car, I have to get my little painting kit out and cover it with other paint, because if I don't, then where it's scratched will rust. And the thing with rust is that it tends to spread. So because it creates quite a flaky surface, where the scratch was on the car, the rust forms, and then that kind of bubbles on the surface and it tends to spread, because then that disrupts the paint barrier around it. In the case of plating in a less reactive metal, that's even more of a problem if it gets damaged. So if the barrier gets damaged in that case, then the corrosion is actually quicker than if the barrier wasn't there at all. So if you think about your tin can, this is why we shouldn't eat food from tin cans that have been dented, because if there's been dented, then you might get a break in the barrier, and then that might start corroding, and then that can cause problems with the food that you want to eat. So the other way of preventing corrosion is something called sacrificial protection. So in everyday language, if we think about a sacrifice, we've all hopefully heard the word before. It's when you offer something up that you consider to have a value, but to get something even more valuable. So it's quite often used in the context of religion. So when we talk about this in chemistry, when we talk about sacrificial protection, that's when we're using a more reactive metal as a sacrifice to protect an object that we want to keep that's made from a less reactive metal. So we want to keep our object that's more valuable to us. So we put a more reactive metal in the vicinity of this so that it then reacts with the chemicals in the environment, so the water and the oxygen, in preference to the object that we're trying to protect. So the main example of this is when we've got ships. So a lot of ships are made from steel, and to protect the steel, because obviously ships go into water and we know that steel rusts. So to protect the steel, because we don't want it to rust, we put magnesium or zinc blocks attached to the hulls. So if you don't know what the hull is, it's the part of the ship which is underwater. And because you've got magnesium or zinc there and they're more reactive, then the water and the oxygen are going to react with the magnesium or zinc instead. And so the steel stays protected. You also need to know about galvanizing. So galvanizing is a specific example of sacrificial protection, but instead of having it in blocks, you actually coat it in it. So it's like the barrier method where you coat it in a less reactive metal, except in this case, we're coating it with a more reactive metal. So galvanizing is when we use zinc. So it acts as a barrier initially, but the advantage of this one is that if the layer of zinc is damaged and the metal underneath becomes exposed, it still doesn't, that metal that we're trying to protect is still protected because the zinc's more reactive than it. So that then continues to protect the object because any oxygen or water is going to react with the zinc rather than the metal we're trying to protect. So that's our advantage. So galvanizing protects the object even when the barrier is damaged. The disadvantage is that the sacrificial metal, because it's reacting, is eventually going to be used up and therefore it's going to need continually replacing. Sometimes in exam questions they ask you a bit more detail about how sacrificial protection works. So we know that corrosion is a redox reaction. The metal's gaining oxygen, so it's easier in this case to think about oxygen because they're reacting with oxygen. So if it's gaining oxygen, we know it's oxidized, but we also know that oxidation is also loss of electrons. Hopefully we've remembered oil rigs, so oxidation is loss, reduction is gain. If you've got a more reactive metal, then it's going to be better at giving away its electrons. So that's going to react in place of the less reactive metal. Right, on to your tasks. So I've given you all the information you need to know. So here's the 5 methods of preventing corrosion. For task 1, I want you to explain the principle behind all the methods. 1 to 4 are basically the same, so you can collect that together. Then you need to explain how method 5 works separately. And then for each of the methods 1 to 5, I want you to name an object that it would be a suitable method for. Right, task 2, I want you to use what you've learned to write a paragraph answering the following question. So you need to give at least 3 reasons why. So there's 2 shipwrecks there, and I want you to explain. So the one on the right is much more rusty than the one on the left. I want you to explain why it might be less rusty, why the one on the left might be less rusty than the one on the right. You can use your knowledge from today's lesson. You can also use your knowledge from the rusting experiments that we set up, if you want to, in the previous lesson. Right, that's mostly it. You've just got to, if you're watching the interactive version of this, you need to answer the quiz questions, which are just about to come up now. Okay, thank you for listening. See you next time.